Okay, so if you're watching this video, you should have already watched the video on the basic rules, including the power rule of derivatives. If you've done that, these examples are going to use those rules to give you just an idea of how more complex derivatives would work. We're still just taking the power rule and applying it to terms that are being added or subtracted. So I'm going to start here with this example. I have y equals 6x to the fourth power plus 3 over x to the second power minus x over 5. The first one is fairly simple to deal with. It's just 6x to the fourth power, so that's going to be an easy derivative using the power rule. Now the second one is a little bit troublesome because it's a quotient, and remember, you can't just take the derivative of the top and bottom. It doesn't work that way. We are going to learn about the quotient rule later on, but first what I'm going to do is I'm going to send this guy upstairs. And that's going to allow me to just have something that's a little bit nicer to work with. I'm still not going to take the derivative. I'm not there yet. But I'm just going to set this up to use that power rule real nicely. So it will be 3x. If I bring it upstairs, that exponent becomes a negative 2. Now I'm going to deal with this x over 5. A lot of people get confused when they see something like this. And I encourage you to rewrite it. There's technically a 1 in front of this x. You could really rewrite this term as 1/5, which is just a number. It's just 1/5 x times x technically. And so that'll make things a little bit easier. People tend to see this as a quotient, which it is, but if you rewrite it as a constant, 1/5 times x, then you can use the power rule, remembering this is a power of 1. So again, I am not taking a derivative yet. I'm just setting this up to be able to use that power rule very easily. So we'll start with the derivative. I'll bring my power forward and I'll multiply by whatever I see there. So that's 24. And then I will subtract 1. So that gives me x cubed. I will repeat the process here in the second term. So that'll be negative 6. X, and subtracting 1 gives me a negative 3. And then I'll bring my power of 1 forward, and that'll give me negative 1/5. But when I subtract 1, that becomes a 0. And so we know that anything to the 0 power is 1. So essentially the variable disappears. And so now this is a good answer, but remember, if it's multiple choice, they're just going to make it a little bit prettier. They're going to leave the 24x to the third power. And they will leave the 6 where it is on the top, but they will send that x cubed to the bottom, and the negative is gone. I've changed its location, and minus 1/5 as we had stated before, and that's the derivative. All right, so let's move on to B. In example B, it looks like it's a quotient, and again, you are not allowed to just take the derivative of the top and just take the derivative of the bottom using power rule. I will discuss a different rule for quotients for things that are being divided. But what we can do, since we don't know the quotient rule yet, is we can simplify this so that it is not a quotient. So for instance, and the reason I can do this is because I'm dividing a binomial by a monomial. If it were flipped, I couldn't do this. But because the denominator is a monomial, I can separate this into 2 fractions. Remember, this is not a derivative. This is just simplifying using algebra to make things look prettier. I don't want it to be a quotient because then I would have to use something called a quotient rule, which we haven't even learned. So if I simplify this is still y equals, I will get 3x to the third power. I subtract those powers, minus 2, and I subtract the powers here, and I get a 2 as well. And now it becomes a really nice function to take the derivative of. All my simplification was legal, so I didn't break any rules. I have 3 times 3 is 9, and I subtract a power, that's 2. And then that's 4, and I subtract a power, and that's 1. So that's actually not a bad problem at all. All right, so C looks a little bit more difficult. Let's see if we can. Basically, we want to arrange this so that the power rule is easy to apply. So here we go. Again, this is not a derivative yet. It's just rewriting this so that I can use the power rule easily. This is just 8 times the square root of x. Remember, the index, if you don't see it here, is a 2. And any time that you have a radical, here is a power of 1. it can be rewritten as a fractional exponent where the denominator is the index and the numerator is whatever power that x has. So the square root of x is really x to the 1/2. And don't let me forget, I actually have an 8 up front. Plus 6. I'm going to rewrite this portion here as a fractional exponent. So the numerator will be a 2, the denominator will be a 3. Now, this piece right here is a little interesting. You have a radical in the denominator, so that's 5 over x to the 1/4, technically. Remember, that's a power of 1, and the index is the denominator. So what I'm going to do is send it upstairs so that it's not a quotient. So I'm going to rewrite that as 5x to the negative 1/4. Remember, I have not taken a derivative. I'm simply rewriting so that I'm able to take the derivative with the power rule. So I'm trying to make my life easier. All right, I'm going to go ahead and apply this rule, the power rule. And it's going to be 1/2 times 8, which is 4. And then I have to subtract 1 from 1/2, which is going to give me a negative 1/2. Then the 2/3 times 6 is going to actually be 6 divided by 3 is 2. So that's actually going to work out to 4. If you need to see that, just 6 times 2/3. That's the same thing as 12 over 3 or 4. And then x. I do need to subtract 1. And remember, 1 is the same as 3 over 3. So this actually becomes negative 1/3. And then plus. Now, that plus is actually going to disappear because when I bring down the negative 1/4 and multiply it by 5, that's going to become negative. 5 times 1/4 is 5/4. And I'm going to go ahead and subtract 1 or 4 over 4. And it's just going to become negative 5 over 4. Okay? This is a perfectly good answer, but if you're looking at a multiple choice exam or assignment, this is not how they're going to present it. They're going to fix those negatives. So we're going to have 4 in the denominator. We'll put x to the positive 1/2 plus 4. 4 stays upstairs, but x comes down. It's now positive 1/3. And minus 5 stays fine. So remember, you only change things with negative exponents, not negative coefficients. The 4 is downstairs, and it's now going to be joined by that x to the 5/4. If you wanted to change these back to radical, you could. This would just be the square root of x. This would be the cube root of x. And this would be the 4th root of x to the 5th power. But you don't need to go that far. Okay? All right, let's take a look at the very last one. And the very last one is pretty much set up for us already. But the reason I put this here is because most people, when they go to take the derivative, they see pi and they think of it as a variable. And they would choose pi to the 4th as its derivative. I want to remind you that pi is simply an irrational number, 3.14, and it continues forever. So actually, if you take pi and raise it to the 5th power, that's not a variable. That's a number. And if you multiply that number by 3, it's just a bigger number. But ultimately, this whole thing is just a number. It's a constant. And the derivative of a constant is going to be 0. Now on the second term, the pi is being multiplied by x squared. So this, imagine, it's just like looking at 3x squared. We would take the derivative by multiplying the 2 and the 3, and then subtracting 1 from the power. So that's the way you got to think about it, because it's now being multiplied by x squared. So this would be 2 pi x. So the derivative is simply 2 pi x. So I hope this helped, and I hope it helps complete your assignment. See you soon.